Hey everyone, welcome back to another course on creating consistent characters. In this video, I'm going to walk you through a new workflow that allows you to create a consistent character. This workflow uses a new model and it produces even more realistic results than the Flux workflow I showed in the previous video. The model we'll be focusing on today is the WAN 2.2 video model. It's been some time since the WAN 2.2 model was first released, and this model has been performing really well, not only in text-to-video workflows, but also in text-to-image workflow. You might be wondering how you can actually use a video model to create images, and I'll be going through that as well. We're also going to learn how to train your own character and build a LoRA that works for both video and image workflows for generating extremely realistic results. We'll be making use of a LoRA called InstaGirl 2.2, which includes two LoRAs for both of our high and low noise models for WAN 2.2. And I'll explain soon why WAN uses two models, which is a low and high noise models, to generate images. The InstaGirl 2.2 LoRA model is designed as a beast layer for your LoRA stack, and it adds the Instagram style aesthetic of realism, where you can add other character or LoRAs on top of it. And I'm going to teach you how to train the character LoRA for the WAN 2.2 model as well. On top of this InstaGirl 2.2 LoRA model, we're also going to be using the Lenovo Ultra Real by Demisi, which is known for boosting realism when used with the InstaGirl 2.2 LoRA model. When it comes to training the LoRA 2.2, we'll be using the AI Toolkit by Ostris, which offers a very user-friendly interface for training a variety of models. In this particular course, though, we'll focus specifically on creating a LoRA for WAN 2.2. Now, for the VRAM requirements, to run the WAN 2.2 model smoothly in Comfy UI, you'll need more than 16 GB of VRAM, but for training, you'll need a minimum of 24 GB of VRAM. And I highly recommend going above that if possible. And since not everyone has access to 24 GB or more locally, we're going to be using Runpod with my setup and choose a much higher GPU setup in Runpod to run our LoRA training. I've provided a Runpod sign-up link in the description below, which contains Runpod template and gives you bonus credits as well, that lets you easily run the WAN 2.2 model in Comfy UI. Now, let's get into running the workflow and see what we need to do in order to train a character LoRA for the new WAN 2.2 model. First, let's open up Comfy UI and load our workflow for WAN 2.22, so I can walk you through each of the individual models being used. If this is your first time using Comfy UI, I recommend going to the official GitHub repo and download the portable version of the program by following the instructions provided on the page. Once you've installed Comfy UI, unzip the folder and run the run NVIDIA GPU.bat file to launch it. Next, head over to the Custom Nodes Manager GitHub repo and install the custom nodes by navigating to the Custom Nodes folder inside your Comfy UI directory and then use get clone with the repository's URL. After you've done this, whenever you drag and drop a workflow, you'll be able to install any missing nodes quickly by just clicking on the Custom Nodes Managers button inside Comfy UI. Once you open up the workflow, you're going to see two different models in the Model Loader section, which is the high noise and the low noise models. The reason why we have two different models for low noise and high noise is because WAN 2.2 uses, which stands for Mixture of Expert Setup, and it's by design to maximize quality and efficiency. iNoise Expert, which kicks in during the early denoising stages where it's kind of responsible for laying out the overall structure, motion, and composition of the video. Once the denoising process reaches a certain point, the model switches to the low noise mode and takes over to refine textures and lighting and define details. You're also able to choose in which step the model switches from the high noise to the low noise model. And you can do that by going over to the K-Sampler Advanced node and tweaking the end at step. The first K-Sampler node is connected to the high noise model, and you can see that it is in total of 10 steps. So about at 40% mark, we're changing over from the high noise model to the low noise model to handle the generation. This design lets WAN 2.2 to effectively function as a much larger model, while only activating the necessary parameters per step keeping inference very efficient. And it's known that the WAN 2.2 model has 65% more images and 83% more videos than WAN 2.1, which enhances the result significantly. You can see as you scroll to the right, there is a LoRA attachment. First one is the high noise LoRA models, and the below is low noise LoRA models. The high noise LoRA model only has one LoRA model, which was from the Instagirl models, and most of the other LoRA models are attached to the low noise model. This is essentially because the WAN 2.2 low noise model is a fine-tuned WAN 2.1, repurposed for the late denoising stages to be combined with the high noise model. The first LoRA models that is attached to the low noise model is this 14 billion light X2V CFG step distill LoRA. This model leverages the light X2V distillation method, which dramatically reduces the inference steps while maintaining the video quality, and the model will allow you to generate video in just 4 inference steps versus the traditional 40+ steps. The LoRA on the right is the Instagirl V2.0 low noise model, and we're also attaching the Lenovo LoRA model, which adds realism on top of the 2.2 model, and the trigger word for the Instagirl and Lenovo LoRA models are in the positive prompt text box. I'm now going to run the generation as an example here. You can use the example prompt on the screen here, but you do need to make sure to put the trigger word Instagram and Lenovo for using the LoRA models. And after waiting for the generation to complete, this is the result image that I got. Compared to the Samsung Ultra Real LoRA model, I would say the image is highly more suitable for the Instagram style. And the model does a really good job on creating an Instagram-style influencer. And it seems like the save image node is bugging out a little bit. But this is another generation of me attempting to create another portrait image of an Instagram influencer. You might be wondering how you can change the workflow to create a video instead of an image. You can go to the empty Juan latent video node and change the length input right here. The length indicates the number of frames the videos will have when the output is generated. Creating a good video of your influencer is extremely useful if you want to create multiple shots in different angles, which can be used for LoRA training, and we'll get into that real soon. As you can see here, you can connect the Bay decode images to the Video Combine node to display the video. You can also set the frame rate right here, which is set to 21 for me, and I generated a 21 length of frames. This means that the video will be a combined length of 1 second. If you're running this workflow for the first time, you might encounter an error that says Res2 sampler is not defined. And to fix this issue, you want to install the RESF custom node. To install it, you want to go to the custom nodes folder in Comfy UI. Git clone the custom node and cd into the folder and copy this command to access the Python exe for your Comfy UI environment. And then pip install r requirements.txt to install all the dependencies. You can find all the commands in the note right here as well. Once you're able to run this either in your local machine or Runpod, which is better in my opinion and cost-effective, we can now move on to AI Toolkit Ostris to train your LoRA for WAN 2.2 video model. To run AI Toolkit for training on WAN 2.2, you need at least 24 GB of VRAM, and that is actually the minimum VRAM requirement to run the training. And that is definitely not suitable for local training environment, and because of this, we're going to use Runpod for training the model. Runpod, in my opinion, is by far the cheapest way to rent a GPU to run in the cloud. To go through the setup, let's go to the pod section first to choose our GPU. To recommend you the GPU option for training, I would recommend A40 if you're on a budget option and you're willing to wait a little bit on the training. RTX 5090 is faster than A40 because it has more CUDA cores and the clock speed is much faster. These two GPUs do suffice in terms of training, but if you do want an even more higher-end GPU to finish your training faster, you can choose any of them from the list here, including the B200. The image name that we're going to select is PyTorch 2.8 with the CUDA version of 12.8.1. We want to modify this template a little bit by clicking the Edit Template button. We want to increase the container disk size and the volume disk size to 200 GB so that we have enough room for both models and the training data. And then you want to scroll down to expose HTTP port section and add the 888 for the Jupyter Lab and the 8675 for the AI Toolkit. Go down to the environment variables and also add the key AI Toolkit Ostris. You can put any value here for your password to get into the AI Toolkit GUI. And you do want to remember this password later on when we load up the program. Once you do that, set overrides, and we just want to deploy. Once your container is up and running, you want to click on the Jupyter Lab and load it up. On the Jupyter Lab notebook, you want to go to the terminal and then ls to check which file you have in the folder workspace. Once that starts running, you will need to start installing all the correct files and the dependencies for you to run AI Toolkit. It's pretty simple, just copy-paste terminal commands. This process takes a little bit of time. Once all the installation completes, you're going to see that the AI Toolkit is available on localhost and it is ready. Once you see that message, you can go back to the Runpod container and click on the HTTP service 8675. And once you're in the AI Toolkit GUI, you want to type in the password that you created for the AI Toolkit Ostris into this access token input field. And then log into the interface. Once you're in the dashboard, you're going to see the GPU that you selected with all the information about the GPU. The first thing that we want to do here is to create datasets. We can create the new datasets by going to the Datasets tab and then create the new dataset. And then we want to enter the name of the new dataset. Once we create the new dataset, we can now add images. For this, you essentially need the image and the caption pair. Unlike FluxGym, that has the automatic caption, using the Florence 2 model, you have to add the caption yourself with the image and the caption pair. The easiest way to create your captions for the images without manually going through all of them and copying-pasting the caption is to upload all your training images to ChatGPT or any of the models of your choice and then copy and paste this prompt right here. This will essentially go through individual images and then create the captions one by one, name individual TXT file with the corresponding image, and then spit back out the zip file of the entire captions. You then need to just download the captions and then unzip it and put the TXT files into your training folder. For me, the name of the individual file is the trigger word, followed by underscore and the number of the image. For creating the datasets for your consistent character, there are a couple of really good workflows you can use. First one is the Flux Context Max and Pro version. You can first create the portrait image on the 2.2 Instagirl workflow and then use Flux Context to create your AI influencer in different views and create different variations of clothes and background. You can also refer to my previous video on setting up Flux Context through Comfy UI API. Another useful workflow that we have is the Play It LoRA from Flux Context. This is an extremely good LoRA that was trained by an individual that is able to do a very high-quality face swap using the Flux Context model. Using the previous 2.2 Instagirl workflows, I was able to create a bunch of different images of random girls with different faces. And then I just load the image of the face of the original portrait image and some of the other images that I generated with 2.2 Instagirl. Using the Place It LoRA with Flux Context, I'm able to generate pretty good face-swapped image and then use it for the dataset. All of the workflows are available on the channel. Once we have the images and the captions ready, you want to click the Add Images button and upload all the files there. Once all the files are uploaded, your dataset is now created. You want to now create a new job to start the training. You can do that by clicking the New Job button. On the Training Job section, you'll come across the trigger name and the trigger word. The trigger name is simply the label you give your LoRA model, and it's often a good idea to set it the name as your trigger word so you don't forget what activates it later. The trigger word, on the other hand, is the actual keyword you'll type in your prompts to call on your trained LoRA. If your training image that we created in the data set previously already have captions, with the trigger word you don't need to change anything. But if they don't, you can set one in this trigger word section here, and it will automatically add that word to all your captions. In the model architecture, you want to select the 2.2 14 billion. You can leave the quantization section as the same. And since we're creating a LoRA model, we have to leave target type as the same as well. If you go to the Save section, the data type here decides the precision and stability of the training math, where BF16 is stable and efficient. FP16 is slightly more precise but less stable, and FP32 is the most precise but slowest and most VRAM heavy. But that precision is not that big of a difference, so it's usually good to just leave this as PF16. The Save Every input here sets how many training steps the model completes before creating a checkpoint. So as an example, you can see here where the checkpoints are being created every certain steps. So you can track progress and test the outputs of the LoRA at regular intervals. For this, we don't need to really modify anything. Batch size is the number of images shown to the model at once during training. When setting the batch size, the main things to watch out for is the VRAM limits and dataset size. A higher batch size helps the model learn a little bit with a finer details because it sees more images at once, but it does require more VRAM. If your GPU doesn't have enough of VRAM, training will crash, and you also need to make sure your batch size isn't larger than the number of images in your dataset. For example, if you have only 5 images, but the batch size is, let's say, 7, the training won't work properly because you don't have enough images. For my case here, I only have 5 images on my dataset, so it makes sense to leave it as 1. But ideally, your dataset contains more than 10 images and as high as maybe 18 images or 20 images. So, you can experiment with higher batch size, for example, like 2 or 3, to see how your LoRA model performed. But usually, I get pretty good result on the LoRA even with a batch size of 1. The steps are the total number of training iterations your model runs through before finishing. If the number of steps is too low, the model will be undertrained. And if it is too high, you'll run into the risk of overfitting. For our case of the WAN 2.2 model, it's good to just leave it as default of 3000 steps. The learning rate controls how quickly the model updates its knowledge each step. Too low, and it learns very slowly, and too high, and it can overlearn or become unstable. So the default setting here is usually the safest starting point. The EMA setting here smooths training by averaging updates over time, making results more consistent and stable, but we can just leave it as off for now in our case. Unloaded text encoder is a VRAM saving option that frees memory after converting captions into embeddings. Normally, the captions are turned into embeddings each step only in the beginning, so you don't need the text encoder later, so you can basically turn it off or unload during the training. So you save up on VRM, but it does slow up training, because if the text encoder is reloaded every time, it's going to take more time for the next step's training. So if you're running this on Runpod with enough VRAM, you can just leave this as unchecked. But if you're running this locally and your training crashes, you can turn this on to save up on VRAM. Next is the dataset. You want to select the correct dataset that you uploaded the images previously. Also set the LoRA weights to 1, because we have only one dataset that we're training on, and you should leave all the other settings as the default. But the important thing here is the resolutions which control the image size your LoRA can train on. The system uses something called bucketing, which means it will shrink your training images down to fit one of the resolution sizes that you pick right here. So let's say, for example, in the dataset, the image is smaller than 512 pixels in either both dimensions. It wouldn't work well for training because the image size is so small. For example, if one of the images in your dataset is 1000 by 1000 pixels, it would basically shrink to 768 by 768. By default, the AI toolkit supports training up to 1536 by 1536. But in practice, most LoRA training works best at 768 or 1024 pixels. But ideally, you'll want your resolution to be above 512 because sometimes I found that the training output images sometimes had blurry background like this. And bumping up the resolution to 768 helped me generate better images. So you can just leave the setting as is right here. If we scroll down to the sample sections, the couple of things that you need to change is the nump frames and the FPS. We want to change both these values to 1 since we're training this based on an image and we're not training it on video dataset. The sample prompts are test inputs that you set during training that the AI toolkit uses to periodically generate images as we go. And it lets you visually check how well your LoRA is learning and evolving at each saved checkpoint, and you can choose which checkpoint you want based on the generated images. For this, you can just go to ChatGPT and generate just 10 example prompts and just copy each prompt into the inputs. And now, all you need to do is click the Create Job button and then start the training. Once the training starts, you're going to see the training happening at incremental steps, and you're going to see the test images that are being generated at each step. And as we said before on the setting, we're going to see each checkpoint being generated at 250 steps. You're going to need to wait a bit of time for the training to complete. And once the training completes, you can download the checkpoint that you wanted that generated favorable images on the samples. Once you download whatever checkpoint version of the LoRA models, place them under the Comfy Charge LoRA folders. Open up the same Instagram workflow on the Comfy UI and on the Low Noise LoRA folders. Let's create another LoRA Loader model only node and then load the trained LoRA model that we created for our character. And then we can simply just control the strength of the model for all of these LoRAs and using the trigger word that we said during the training. Just a small note here, I retrained my LoRA with the trigger word of woman instead of Amy. So, I'm going to use this woman LoRA instead. And with the new generated LoRA model, I'm going to be testing it with this example prompt. I'm setting the trigger word right here, woman, which is kind of a vague trigger word, but this is what I use to create a LoRA model. For the strength of the LoRA model, I'm using 1.0, but you can change this to however you want, depending on what result you get. And here is the generated outcome. And indeed, the character does look very consistent with our training data. Even though I used 5 images for the dataset, the outcome is pretty good, and it's able to also be pretty flexible with the outfit by identifying the red bikini. And I think this LoRA could definitely be improved with more diversified dataset, with more expressions and different poses for the model. And all of that workflow can be found here on the channel. But overall, the settings of the AI took a pretty good job in training the LoRA model with a limited number of training images. Well, I hope you guys enjoyed this video on creating the consistent character on 1.2.2 model. If you had any questions on training resources, you can ask the questions below in the comments section. I'll be back with more AI content, and thanks for watching.